What is NMR? NMR is nuclear magnetic resonance. Organic molecules are mainly composed of carbon and hydrogen. And to figure out the structure of organic molecule, distinguishing different carbon and hydrogen atoms are important. This is one of the earliest proton NMR spectrum obtained for organic molecules. The molecule is ethanol, and this spectrum was taken in 1951. Looks like quite poor quality, isn't it? But this was the scientific turning point to show the possibility of distinguishing different hydrogen atoms in spectroscopy. This ethanol NMR shows the different environment around each different hydrogen nucleus. Of course, in modern days, we can get much better NMR spectrum with lots of information, including chemical shift and coupling constants. As NMR is so powerful to analyze the organic molecules, even some people say, after NMR is developed, no more research. That's another abbreviation of NMR. With this great potential, multiple Nobel Prizes were awarded to NMR techniques during the last half a century. Let's think about the mechanism of MRI. Hydrogen nucleus has a spinning effect. If a charged particle spins, it behaves like a small magnet. So we can say we have many small magnets in our body, but they may be oriented randomly. If you apply strong magnetic field from outside, the magnets can align. Then we can say our body is magnetized. As the nuclear magnets are not static and quantized, the direction can be either up or down. Depending on the directions, under a strong magnetic field, there can be two populations of magnets. If they are different in energy level, by applying electromagnetic wave, we can excite the lower energy magnet into higher energy level. This is quite similar to excitation of an electron from lower energy to a higher energy level. What range of light did we use for the electronic transition? Do you remember? It was either in UV or visible light range. Nuclear spinning is much slower, and also the energy gap is quite small. The required energy for this transition is microwave, which has a much longer wavelength than visible or even infrared light. This range of electromagnetic wave is in megahertz range, which may be familiar with you as 300 or 500 megahertz NMR. If electrons are not paired, they also behave like a magnet with a spinning effect. Then, similar type of energy absorption is possible in magnetic field. The energy level is in gigahertz range, which is much higher than NMR. And this ESR, electron spin resonance technique, is very useful to check whether the molecule has a radical in it. After excitation, if the irradiation of radio frequency is stopped, the excited state nuclei can be relaxed, releasing the electromagnetic wave. The different energy gap for these two states for different hydrogen is the basis of chemical shift in NMR.